Chapter 3, 3.1 to 3.3. Again, the practice questions are not optional. Everything else is optional. And here's the formulas that would have to do with this section from your actual information booklet. So to start off, we're going to talk about sequences. So a sequence is essentially a list of numbers that usually have a pattern. We're going to talk mostly about arithmetic and geometric in this section. So we also want to get these defined. Finite sequence is a sequence that has a last value. When we talk about infinite sequences, the sequence never ends. And a sequence is essentially a function, and the function is usually written in two forms: explicit, which is what you'll be used to a little bit more. Given the x value, you can find the y value. The function can also be written in a recursive form, which we'll go into a little more depth later, but a recursive form means you have to know the term before to get to the next term. So you have a bunch of formulas that are given to you. So what we have here is considered an explicit formula. How do I know it's explicit? Because if I know the n value, so if I say n equals 5, then I can find the b of 5. So the problem asks you to find the first 5 terms. We're not going to go through all of them, but obviously b of 1 would be equal to 2 minus 1 over 1 squared. And the 50th term would be b of 50, which is equal to 2 minus 1 over 50 whole thing squared. So this is considered an explicit formula because if I want to know the 50th term, I can find it very easily. I don't need the term before it, which would be the 49th term. So that's your explicit rule. Explicit rules, if you know the input, you can easily find the output without knowing prior terms. Recursive rule. So recursive rules are always written the same way. You need some kind of starting statement. So usually starting statements will be something like a sub 1 equals a value, or it'll be a sub 1 equals a value and a sub 2 equals a value. And it really depends on the definition that you use for the rule. Secondly, you need a rule to find the next term. And the next term is really the important thing. So what I mean by that is usually you'll have your A1 or your A2, and then you'll have A sub n is equal to some function that has an A sub n minus 1 in it. So if I do something like this, this would be an easy one. This says to find the nth term. On this side it says multiply by 2. And this says the term before the nth. So what that tells us is I just need to know the one before it, and I will be able to find the next term. So that's recursive. So let's do an example just to make sure you understand the definition. So find the first 5 terms and the 20th term of the sequence. We will not be finding the 20th term because it's going to take a very long time. So this right here is considered our starting statement. Also, you could call it your initial. I don't know why this is not changing. Here we go. That's the initial statement. And then this over here says, and we're going to translate it, to find the nth term, which is b sub n. We're going to start from the inside of the parentheses. It says take the term before, which is b sub n minus 1, add 3, and then we're going to multiply by 2. In this order. What you really want to notice, if this is n, then this b over here uses n minus 1. So if I want the 20th term, and here's a reason we're not going to find it, I would have to know 2 times the 19th term plus 3. But I don't know the 19th term, I only know the first term, so therefore I would need the 18th, which in turn, pretty much you would have to start from b sub 1, go all the way up. So let's just at least find the first few terms so you understand how to use it. If b sub 1 is equal to 5, if I asked you to find b sub 2, it would be 2 times b sub 1, the term before it, plus 3, which in this case would be 8, so 16. B sub 3 says I would take 2 times b sub 2 plus 3, and so on. What you'll notice is if this was explicit and I asked you to find the 20th term, you would substitute 20 into a formula and get the 20th term. Here, for a recursive, if I want the 20th term, I need to know all the ones before it because of the definition given. So arithmetic sequence, pretty much a linear function. So it's exactly the same as a linear function. And if you know that, the reason why it's the same, there's something called a common difference. The common difference would be considered our slope. So I always find it interesting that they give you all these formulas for an arithmetic sequence, but in reality, you can use all your knowledge of lines to actually do any arithmetic sequence problem. So arithmetic sequence is given right here. That is the recursive formula. So the recursive formula says take the term before and add the common difference. So term before, and this here is your common difference, which is also essentially your slope value. If you want to find the nth term of an arithmetic sequence, right here is your formula. I'll write it a little bit bigger. A sub n is equal to the first term plus however many terms I want, take away 1, times the common difference. So if you want to find the nth and the 50th terms of the sequence, you would first have to find you need some information. You need a sub 1, you need the common difference, which from here to here, I'm adding 8. So the common difference is 8. So a sub n, and what I'm going to do is actually show you the formulas that you're given, which, ooh, I forgot that I did that. So you'll see here the nth term of an arithmetic sequence. That is how it looks on the formula sheet. You'll notice that this is your a sub n, this is your a sub 1. They use u instead, so I wanted you to notice that the formulas will look different. So what I'm going to do here is change this so it actually says u, so that you get used to that. U sub n would be equal to your u sub 1 plus n minus 1 times d. So a lot of this is really just you substituting in formulas and hopefully being able to figure everything out. So I wanted to find the nth term, so that would be 2 n minus 1, the common difference being 8. A lot of times they'll simplify it so that it looks like y-intercept form. So you'll notice if I distribute the 8, I actually get that u sub n is equal to 8n minus 6. Looks just like a linear function because it is. This is your slope, which is the same as the common difference. This is your y-intercept, which is the same as u of 0. And then it asks to find the 50th term. So u sub 50 would be very easy. I would do 8 times 50 and then minus 6, and you would get your 50th term. Find the recursive and explicit form of the definition of the following and then calculate the value of the 25th. So if you look here, we are subtracting 5 and you just want to make sure that it happens each time. So this is an arithmetic sequence. Again, we're going to show the formula. And the recursive is where we'll start. Recursive formula, you start with the very first term, which is 13. To get the next term, you can literally consider this a sub n the next term. I would take my term before it. You can literally just keep saying term before. So take the term before and subtract 5. So that would be my recursive formula. To find my explicit, I would find my a sub, well, oh, I guess I shouldn't use a, I should have been using u. So u sub n is equal to the very first term plus the n minus 1 terms times the common difference, which is negative 5. So that is the actual explicit formula. They may ask you to simplify that. I'm going to leave it like this in case you need to also. And then it asks you to find the 25th term. So u sub 25, that's the same thing as you doing something like this. Function notation. The input is 25. The output is u of 25. So I would do 13 plus the 25th minus 1 times negative 5. And that would give you the 25th term. Find a definition whose first term, so u sub 1 is 5. And the fifth term, u sub n, u sub 5 is 11. So that would just be you using the formulas. You have your u sub 1, so you can do u sub n is equal to u sub 1 plus n minus 1 times d. And if you substitute things in, this is your u sub n. So that would be 11. Your u sub 1 would be 5. Plus your n is this 5 sitting here, so this is 5 minus 1. We just don't know the common difference. So I'll be able to find the common difference, which is the only thing I really need to write the definition. So 11 is equal to 5 plus 4d. So 4d is equal to 6. Wow, it's early. D is equal to 3/2. So your actual formula would look like u sub 1 plus n minus 1 times the common difference of 3/2, and then you can simplify it. Arithmetic mean. Insert 4 arithmetic means essentially means that given that you have the first, the second, the third, the fourth, let's see, you're going to find the terms in between 3 and 7 that would be an arithmetic sequence. So this would be a common difference. So I'm just going to use common sense. If I start with if I start with the initial value that they gave us, 3, I would be adding 1, 2, 3, 4, 5 common differences to get to 7. And so then I'll just find the common difference that is in between. So it would be 5d is equal to 4. So d is equal to 4/5, which is the same thing as 0.8. So I'm going to add 0.8 each time. So it would be 3.8, 4.6, 5.4, 6.2, and then there we go, 7. So my 4 arithmetic means would be 3.8, 4.6, 5.4, and 6.2. So common difference is essentially saying that I need to find these values in between, where if I put them in between, I'd be adding the same value to get from the first to the last. Geometric sequences. The definition of a geometric sequence, they will start you with the recursive formula. So I'll write that a little bit larger. A sub n is equal to a sub n minus 1 times r. R is your common ratio. So this is where you are multiplying or dividing by a value. And then the nth term, so the explicit formula, write it a little bit bigger for you, would be a sub 1 times r to the n minus 1, okay? And order of operation says you cannot multiply first. Have to do the power first, okay? That's the only major mistake I usually see. So, and again, on your formula sheet, they actually use u sub 1, u sub n, so make sure you know that that's exactly the same thing. So there are a few problems here. Basic one would be letter A, just being able to use the formula. So let's copy that here. So here's our formula. Letter A, find the geometric sequence with a sub 1 equal to 2. So there's a few ways you could write the terms, or you could find u sub n, which would be u sub 1, which is 2, times the common ratio to the n minus 1. So that would actually give you the value for the nth term. Other thing that's really interesting is sometimes you'll see that the exponent is only n. The way that happens is 2 times 3 to the n times 3 to the negative 1 is actually the same thing as n minus 1. These have the same basis, so I could essentially add the powers and simplify backwards to get this. That's what you're a little bit more used to. So really, the other way that you would see this, 3 to the negative 1 is 1/3, so I would do 2 divided by 3 times 3 to the n. And you'll notice that this looks like an exponential function. A geometric sequence is essentially an exponential function. All right, so describing the sequence, just making sure you understand the concept of the r. You're essentially looking for the value that multiplies to get to here. In this case, you're multiplying by -4. And graphing a sequence, I just wanted to make sure you understood that. When you graph a sequence, part D, a sub n is equal to 1/4 times 3 to the n minus 1. You should only be graphing points. This is not an actual curve, meaning there are literally going to be points in the form of an exponential curve, and it will be a scatter plot. So if I wanted to graph this very quickly, so I have the very quick graph to sketch. So the first term is 0.25. I would put the point. The next term being 0.75. The third term being 9/4, which is 2.25. Fourth term, which would be 27/4, which would be 6.75, I believe. Okay. So you actually don't connect the dots or the points. You actually leave it as a scatter plot, because a sequence only can be defined where your n values or your x values are within the natural numbers except 0. I believe your book in the IB defines sequences starting with n equal to 1 and not n equal to 0. And you'll have some word problems that you have to be able to solve that are going to be some type of sequence. So obviously this one coming in the geometric sequence section will be so. At 8 a.m., let's just write down some important information. There is 1,000 milligrams of medicine administered to a patient. At the end of each hour, the concentration is 60%. So this is a decrease by 60% of the amount present. What proportion of the medicine remains in the patient's body at noon? So letter A, you want to know for noon. That would be that the n is 4 hours later. So this is geometric because we're decreasing by 1%. Anytime you decrease or increase by 1%, it is going to be geometric. So u sub 4 is equal to the u sub 1 times r, common ratio, to the n minus 1. So u sub 1 is 1,000 milligrams is where we're starting. My common ratio, I'm going to decrease by 60%. What that means is I'm keeping 40% of what's there. So really what I'm going to do is a 1 minus the 0.6 to the n minus 1. So really what you'll see is that I actually have 0.4 as my common ratio to the third power. So decreasing by 0.6 is the same as increasing by 0.4. As I'm sitting here looking at this, I just realized that since we're starting with 1,000 milligrams, my n should actually be 5, and I'm sorry about that. I'll do it in a different color. The reason being, if n was 1, this would actually give me an exponent of 0. Anything to the 0 is 1, so I'd be left with u sub 1. So that tells me that my n value should actually be 5 and not 4. It's the way that arithmetic and geometric sequences are written. They are related to exponential functions, but because of the exponent being minus 1, your count is slightly off by 1. It's very odd, but I usually have to find the first term. So my first term is here. This is when n equals 1. So if I substitute n equal to 1, I'll get 1,000 back again. Therefore, if I want to go until noon, it'd be n equal to 5. All right, moving on. Compound interest. Compound interest, you want to make sure that you note what type of compounding is happening. So in this case, we'll do the example. You can see the formula here. So example 9, it's in euros because the book is European apparently. All right, so 1,000 euros is invested. You're going to pay compound interest at a rate of 6%. So this is our R. 6% would be 0.06. R must be in the form of a decimal. Calculate the amount of money in the account after 10 years. So this here is our time. Time is equal to 10. This is our initial amount, which is P. So given everything that you have in that formula, we will do B, compounding quarterly. So your final amount, which is A, is equal to the initial amount P multiplied by 1 plus the rate as a decimal divided by how many times you compound. If you're compounding quarterly, we compound 4 times in a year. I would do 4 times 10. Things that I really suggest, if you're going to put this in the calculator, change that to 40. Most people will forget to put the exponent in its own set of parentheses. You essentially, in the calculator, must do this or it will calculate the value incorrectly. Compounding, the more you compound, the more money is made. So if you are trying to get the most money from an interest-bearing account, you want the account to compound the most. So in the A, B, and C, you will make the most money by compounding monthly. So here you want to invest 1,000 euros. What interest rate is required to make this investment grow to 2,000 euros in 10 years? Again, you're just using a bunch of formulas. So compound interest, you want it to be 2,000, so that would be my ending amount. I'm starting with 1,000. 1 plus the rate, I don't know, but I'm going to divide by compounding quarterly times 4 times 10 years, which would be 10, so that's 40 up top. So you're solving this, which would be 1,000. I was going to divide by 1,000, which would give me 2 is equal to 1 plus R over 4 to the 40th. Then you would take this to the 1/40th power. Subtract 1 from it. So I'm going to do it without the calculator. I'm just going to write down everything I would do. And then multiply by 4. And that would be my R value. All right, so